AWS Certified Solutions Architect Associate Study Notes. AWS Command Line Interface, CLI. The AWS CLI allows users to create, manage, and delete AWS resources directly via the command line interface. It's a powerful tool for automating tasks without needing to go through the AWS Management Console. It provides direct access to AWS services and is commonly used for scripting or repetitive tasks. Key concepts. Access keys. Access keys consist of an access key ID, like a username, and a secret access key, like a password. These keys allow an IAM user to authenticate their CLI commands and perform actions as if they were logged into the AWS console. Note: do not share access keys. Use the principle of least privilege. Ensure you specify the correct region using the region flag or by configuring it globally using AWS Configure. AWS SDKs, Software Development Kits. AWS SDKs allow developers to interact with AWS services directly from their code. SDKs are available in multiple programming languages such as Python, Moto 3, JavaScript, Java, Ruby, etc. Specialized SDKs exist for IoT and mobile platforms. AWS SDK versus CLI. The AWS CLI is useful for command line automation, whereas the SDK allows programmatic access through code. AWS EC2 Instance Connect. EC2 Instance Connect is a service that lets you SSH into EC2 instances without requiring SSH keys to be stored locally. The connection is initiated via the AWS console, allowing quick and easy access to EC2 instances. Requirements. You must allow SSH access through the security group attached to the instance. Benefits. No need to distribute SSH keys. Simple, one-click access from the AWS console. Identity and access management. IAM is the foundation of security in AWS, controlling permissions and access to AWS resources. It is a global service, meaning that it operates across all AWS regions. Best practices. Root user. Only use the root account for initial setup and billing purposes. Avoid using it for day-to-day operations. Individual user accounts. Each user should have their own IAM account, and permissions should be assigned through groups and policies. Password policies. Implement a strong password policy, minimum length, complexity, and rotation. Multi-factor authentication, MFA. Enforce MFA for added security, especially for privileged users. Roles for services. Use roles for granting permissions to AWS services. For example, EC2 accessing S3. Least privilege principle. Always grant users the minimum permissions necessary to perform their job. IAM components. Users, real people or applications that need access to AWS services. Groups, a collection of users with similar access permissions. Roles, temporary permissions for AWS services or users, cross-account access, service access. Roles versus resource-based policies. When assuming a role, you temporarily drop your existing permissions and gain the permissions of the role. Resource-based policies can be used to control access to specific resources, like S3 buckets, across accounts. IAM security tools. IAM Credentials Report provides a list of all IAM users and the status of their credentials, passwords, access keys, MFA. IAM Access Advisor shows the services a user has access to and the last time they accessed them, helping to review and refine permissions. Use case. Securely manage access to AWS services and resources by creating and controlling users, groups, and permissions. Example, a company wants to ensure that only the database administrators can access Amazon RDS instances. They create an IAM group called DB admins and attach a policy granting full access to RDS. Only users added to this group can perform database management tasks. Federated access and identity services. AWS IAM Identity Center, AWS Single Sign-On. Description: enables you to centrally manage access to multiple AWS accounts and business applications. Features: integration with external identity providers, support SAL 2.0, enabling integration with corporate directories like Active Directory. Centralized access management, manage user access from a single location. Use case: centralized access management across multiple AWS accounts and applications, allowing users to sign in using corporate credentials. Example: an organization uses Microsoft Active Directory for employee authentication. By integrating AWS IAM Identity Center with their Active Directory, employees can access AWS resources across multiple accounts using their existing login credentials. AWS Security Token Service, STS. Description: provides temporary security credentials for users to access AWS resources. Use cases: federated users, grant temporary access to users authenticated outside AWS. Cross-account access, allow users from one AWS account to access resources in another account. Example use case: scenario: an enterprise wants its employees to access AWS resources using their corporate Active Directory credentials. Solution: use IAM Identity Center to federate access. Employees log in using their corporate credentials, and IAM roles are used to grant access to AWS resources. Use case: provide temporary, limited privilege credentials for users or applications that need to access AWS resources. Example: a mobile application needs to upload images to Amazon S3 on behalf of users. The app uses AWS STS to obtain temporary credentials, allowing users to securely upload images without embedding long-term access keys in the app. AWS Organizations and Service Control Policies, SCPs. AWS Organizations. Description: enables you to create groups of AWS accounts and apply policies to those groups. Features: consolidated billing, combine billing across accounts. Centralized management, manage policies, security, and compliance across accounts. Use case: centrally manage and govern multiple AWS accounts, apply policies, and consolidate billing. Example: a large enterprise has separate AWS accounts for each department, for example, HR, finance, IT. Using AWS organizations, they consolidate billing and apply security policies uniformly across all accounts. Service control policies, SCPs. Description: policies that centrally control permissions for accounts in your organization. Features: permission boundaries, define the maximum available permissions for accounts. Inheritance, policies are inherited by child organizational units. Example use case: scenario: a company wants to prevent any AWS account in its organization from launching resources in specific regions due to compliance reasons. Solution: use an SCP to deny access to those regions. Attach the SCP to the root or specific organizational units, OUs, as needed. Use case: enforce governance by restricting AWS services and actions that accounts, organizational units, OUs, or entire organizations can access. Example: to comply with regulatory requirements, a company wants to prevent any AWS account from launching resources in regions outside the United States. They apply a SCP that denies access to non-US regions across all accounts in the organization. Resource policies and cross-account access. Resource policies. Description: JSON policy documents attached to resources like S3 buckets or SQS queues to define who can access them. Cross-account access. Methods. Resource-based policies attach a policy directly to the resource granting access to another account. IAM roles with external trust create a role in account A that trusts account B, allowing users in account B to assume the role. Example use case: scenario: accountant needs to read objects from an S3 bucket in account B. Solution: option 1. In account B, attach a bucket policy to the S3 bucket granting read permissions to account A's IAM user or role. Option 2. In account B, Create an IAM role that grants read access to the bucket and allows users from account A to assume the role. Design secure workloads and applications. Securing applications. Application configuration and credential security. Best practices. Do not hard code credentials. Avoid embedding access keys in application code. Use IAM roles. For services like EC2, assign an IAM role to the instance to grant permissions. AWS Secrets Manager, store and retrieve sensitive information like database passwords or API keys. Example use case. Scenario: an application running on EC2 needs to access a database and S3 buckets securely. Solution: assign an IAM role to EC2, grant the necessary permissions to access S3. Use AWS Secrets Manager, store the database credentials and retrieve them securely within the application. Network security. VPC security components. Security groups. Stateful firewall controls inbound and outbound traffic at the instance level. Rules allow traffic based on protocols, ports, and source/destination IPs. Network access control lists, NACLs. Stateless firewall controls traffic at the subnet level. Rules allow or deny traffic, evaluated in order. Route tables. Definition: determine when network traffic is directed. Use case: control traffic flow between subnets and to the internet. Network segmentation strategies. Public subnets. Description: subnets with a route to the internet via an internet gateway. Use case: host public-facing resources like web servers. Private subnets. Description: subnets without direct internet access. Use case: host backend servers, databases. Example use case. Scenario: deploy a 3-tier web application with web servers, application servers, and databases. Solution: web servers in public subnet, accessible from the internet. Application servers in private subnet, communicate with web servers. Databases in private subnet, accessible only by application servers. Security measures. Security groups restrict traffic to necessary ports, for example, port 80 for web servers. NACLs add an extra layer of security to control traffic at the subnet level. Integrating AWS security services. AWS Shield. Standard, automatic protection against common DDoS attacks. Advanced, paid service offering enhanced protection, including dedicated support. Use case: protect applications against DDoS attacks. Example: an online retailer experiences a sudden spike in traffic due to a DDoS attack during a sales event. AWS Shield Standard automatically mitigates the attack, keeping the website operational. AWS Web Application Firewall, WAF. Features: protects against SQL injection, cross-site scripting. Integration: works with CloudFront, ALB, API Gateway. AWS Secrets Manager. Features: secret rotation, automatically rotates secrets. Integration: works with RDS, Redshift, DocumentDB. Example use case. Scenario: a web application needs to protect against common web exploits and manage database credentials securely. Solution: use AWS WAF attached to the ALB to filter malicious traffic. Use AWS Secrets Manager, store and rotate database credentials. Securing external network connections. VPN connections. Site-to-site VPN. Use case: securely connect on-premises networks to AWS VPCs. Client VPN. Use case: allow remote users to securely access AWS resources. AWS Direct Connect. Description: provides a dedicated network connection from your premises to AWS. Benefits: increased bandwidth, higher throughput compared to internet-based connections. Consistent network performance, lower latency, more reliable. Example use case. Scenario: a company requires a secure and high bandwidth connection between its data center and AWS. Solution: implement AWS Direct Connect, establish a dedicated line. Security measures: use private VIFs, virtual interfaces, for private communication. Optionally, use VPN over Direct Connect for encryption if required. AWS EC2, Elastic Compute Cloud EC2 is a fundamental compute service providing virtual machines on demand. It's one of AWS's oldest and most widely used services. EC2 features: operating systems. EC2 supports Windows, Linux, and Mac OS. Instance types. Different instance types provide varying combinations of CPU, memory, and storage for different workloads. User data, a script that runs once at instance startup, often used for initializing instances, for example, installing updates or software. EC2 instance types: general purpose, balanced CPU, memory, and networking, for example, T3, M5. Use cases: web servers, small databases. Compute optimized, high CPU for compute-intensive tasks, for example, C5. Use cases: high-performance computing, batch processing. Memory optimized, high memory for memory-intensive tasks, for example, A5. Use cases: large databases and memory caches. Storage optimized, high disk throughput, for example, I3. Use cases: NoSQL databases, data warehousing. EC2 purchasing options: on demand, pay for compute capacity by the hour or second with no long-term commitments. Reserved instances, significant cost savings over on-demand pricing for 1 or 3-year terms. Spot instances, purchase unused EC2 capacity at a discount, but instances can be interrupted if AWS needs the capacity. Dedicated hosts, physical servers fully dedicated to your use, often used for compliance or licensing reasons. EC2 placement groups. Cluster, instances are placed close together in a single rack, offering low latency but less fault tolerance. Spread, instances are placed across distinct hardware, offering higher availability and fault tolerance. Partition, instances are divided into partitions, where each partition is isolated from failures in other partitions. Use case: provide resizable compute capacity in the cloud to run applications on virtual servers. Example: an e-commerce website runs its web servers on EC2 instances. During peak shopping seasons, they use auto-scaling to add more instances to handle increased traffic, ensuring a seamless user experience. Amazon Machine Images, AMIs are pre-configured EC2 instance templates. They allow users to launch instances with a specific configuration, including operating systems, application data, and software packages. Types of AMIs. Custom AMIs, created from a running instance with all the required configurations. Marketplace AMIs, pre-built AMIs available for purchase, often including specialized software. App Runner. App Runner is a fully managed service that makes it easy for developers to deploy web applications and APIs without needing to manage any underlying infrastructure or server configurations. Features: managed deployments. App Runner automatically builds and deploys your applications based on your code repository or a container image. Scaling. It automatically scales the application based on the traffic and workload. No infrastructure knowledge required. You do not need to worry about managing EC2 instances, load balancers, or auto-scaling groups. Built on ECS and Fargate, App Runner runs applications using AWS ECS, Elastic Container Service, with AWS Fargate for fully serverless deployments. Use cases: deploying simple web applications, microservices, and APIs. Ideal for developers who want to focus on writing code instead of managing infrastructure. AWS Batch. AWS Batch is designed for large-scale, high-throughput batch processing. It simplifies the scheduling and orchestration of batch jobs and provisions the necessary compute resources on demand. Features: Fully managed, AWS Batch manages the infrastructure required for batch jobs. You don't need to worry about EC2 provisioning or scaling. Dynamic resource provisioning, batch jobs dynamically provision EC2 on demand or spot instances based on job requirements and budget. Job definitions, you define jobs and specify the computing resources needed, such as POO, memory, and storage. No server management. While it's not completely serverless, AWS Batch abstracts away most infrastructure concerns. Use cases: big data analysis, media transcoding, simulations, and scientific computing. Processing large datasets for machine learning pipelines. Batch versus AWS Lambda. Batch has no runtime limit, making it suitable for long-running jobs, while Lambda has a maximum execution time of 15 minutes. Batch supports custom runtime environments and flexible instance types, while Lambda is designed for smaller tasks. AWS Elastic Compute Cloud, EC2, Autoscaling. Autoscaling allows you to automatically adjust the number of EC2 instances in your application based on traffic or performance metrics. Key components. Launch configuration defines the type of EC2 instances, including AMI, instance type, and security group. Autoscaling group specifies the minimum and maximum number of EC2 instances that should be running, and in which availability zones. Scaling policies. Target tracking keeps the metric, like CPU utilization, at a specified target. Step scaling adds or removes instances in response to larger changes in metrics. Schedule scaling scales based on predefined schedules. Use cases: web applications with variable traffic, for example, e-commerce, SaaS platforms. Compute-heavy applications that require dynamic scaling based on load, for example, machine learning inference. AWS Fargate. AWS Fargate is a serverless compute engine for containers that works with both Amazon ECS and Amazon EKS, Kubernetes. It removes the need to manage EC2 instances while still allowing you to run containers. Features: serverless, you don't manage servers, AWS provisions compute resources automatically. Pay per use, you only pay for the POO and memory resources your containers consume. Scalable, Fargate automatically scales up and down as needed. Use cases: containerized microservices or APIs where managing EC2 infrastructure adds complexity. Short-lived batch jobs or task-based workloads that require elastic scaling. Use case: run containers without having to manage servers or clusters, focusing on designing and building applications. Example: a microservices application uses AWS Fargate with Amazon ECS to deploy containerized services. Developers can deploy and scale containers without worrying about the underlying infrastructure. Elastic Beanstalk. Elastic Beanstalk is another managed service that allows you to deploy and manage applications without worrying about the underlying infrastructure. However, unlike App Runner, Elastic Beanstalk provides more control over infrastructure if needed. Features: automatic scaling. Elastic Beanstalk automatically handles the scaling of your application based on traffic. Support for multiple languages, supports Java, .NET, Node.js, Python, Ruby, Go, Docker, and PHP. Infrastructure management. Although you don't need to manage EC2 instances directly, you have the option to modify instance types, scaling policies, and other configurations if desired. Customizability. Unlike App Runner, Elastic Beanstalk allows more control over the environment post-deployment. Use cases: quick deployment of web apps with more control over infrastructure than App Runner. Applications requiring auto-scaling but minimal operational overhead. AWS Lambda. AWS Lambda allows you to run code without provisioning or managing servers. You upload your function code, and AWS Lambda runs your code in response to triggers, for example, an API call, file upload, or scheduled event. Key features: serverless, you do not need to manage infrastructure. Lambda abstracts all server management. Event-driven, AWS Lambda automatically triggers functions in response to events from services like S3, DynamoDB, API Gateway, SNS, etc. Scalability automatically scales based on the number of incoming requests or events. Common triggers. API Gateway creates serverless APIs. S3 process files uploaded to S3 buckets, for example, image processing. CloudWatch events trigger scheduled tasks, for example, cron jobs. Limits and considerations. Execution time. Lambda functions can run for a maximum of 15 minutes. Memory allocation. Functions can use between 128 megabytes and 10 gigabytes of memory. Stateless. Each invocation of a Lambda function is stateless, meaning that no data persists between invocations, unless using /tmp or external storage like S3. Use cases. Real-time file processing, for example, converting images or videos. Event-driven automation, for example, log processing. Lightweight microservices. Use case. Run code without provisioning or managing servers, paying only for the compute time consumed. Example, an online retailer uses Lambda functions to resize and watermark product images uploaded to S3. The function is triggered automatically upon object creation, eliminating the need for a dedicated server. Amazon Cognito. Amazon Cognito is used to manage authentication, authorization, and user profiles for your applications. It provides both user pools for managing users and identity pools for managing temporary AWS credentials for users. Cognito user pools. User directory acts as a directory for managing users in your app. Authentication supports federated sign-in with third-party providers, for example, Google, Facebook, Apple. MFA support, multi-factor authentication for added security. Customizable UI, you can customize the sign-in /signup UI. Cognito identity pools. Temporary AWS credentials. Identity pools are used to assign AWS credentials to authenticated users. Access control, you can control access to AWS resources based on the user's identity. Use cases. User authentication and authorization for web and mobile applications. Secure temporary access to AWS services like S3 and DynamoDB for authenticated users. AWS Control Tower. AWS Control Tower simplifies the setup and governance of multi-account AWS environments. It works in conjunction with AWS organizations to help centralize the management of multiple AWS accounts. Benefits. Automated setup. Control Tower automates the setup of multiple AWS accounts, applying best practices around security, monitoring, and compliance. Guardrails. Provides preventive and detective guardrails to enforce governance across accounts. Dashboard. Centralized view of compliance and policy violations. Use cases. Setting up new AWS accounts and environments that adhere to corporate governance policies. Managing compliance and security across a large organization with multiple AWS accounts. Amazon Elastic Transcoder. Amazon Elastic Transcoder is a fully managed service for converting media files stored in S3 into different formats suitable for playback on various devices. Features. Scalability automatically scales to meet the volume of media transcoding jobs. Pay-per-use charges are based on the amount of media you transcode. Preset conversion settings offers pre-configured settings for different output formats, for example, different screen resolutions, codecs. Use cases. Video and audio format conversion for content delivery networks, CDNs, mobile applications, or streaming services. Amazon Systems Manager, SSM. AWS Systems Manager provides a unified interface for managing and automating operational tasks across AWS resources, like EC2 instances, RDS databases, and even on-premises servers. Key features. Session Manager allows you to access and manage EC2 instances without needing SSH or opening inbound ports. It works with instances in both public and private subnets. Benefits: no need for SSH keys, no open ports, and you can log the session to S3 or CloudWatch for audit purposes. Run command allows you to remotely execute commands on EC2 instances or on-premises machines without needing SSH access. Patch Manager automates the process of applying patches to EC2 instances based on defined compliance baselines. Parameter Store, secure storage for configuration data and secrets, for example, database connection strings, passwords, and API keys. Automation allows you to create automated workflows for managing AWS resources, for example, restarting instances, managing backups, or configuring applications. Use cases: Session Manager, securely access instances in private subnets for troubleshooting. Patch Manager, automating the regular patching of EC2 instances for compliance and security. Parameter Store, securely store and retrieve environment variables and application configuration. AWS Directory Service. AWS Directory Service enables you to run and manage Microsoft Active Directory AD on AWS, making it easier to manage your users and access to AWS resources. Versions of AWS Directory Service. AWS Managed Microsoft AD provides a fully managed Microsoft Active Directory in the AWS cloud. Can establish a two-way trust with an on-premises AD to integrate existing directory services with AWS. AD Connector acts as a proxy to redirect AD authentication requests to your on-premises AD without caching credentials in the cloud. Simple AD, a standalone directory service in AWS, but with limited functionality compared to AWS Managed AD. Use cases: centralized authentication and authorization for applications running on AWS using corporate credentials. Integration of AWS services, for example, Amazon Workspaces, Amazon RDS for SQL Server, with existing on-prem AD. AWS Organizations. AWS Organizations simplifies the management of multiple AWS accounts and provides central governance over billing, policies, and security across an enterprise's AWS environment. Key features: consolidated billing, manage the billing of multiple AWS accounts under a single umbrella account. Root account, which aggregates usage for potential cost savings, like reserved instances or savings plans. Service control policies, SCPs, centralized control over what actions can be performed across all or specific accounts in the organization. These policies allow for enforced security controls, for example, disallow certain regions, limit service usage. Account grouping, organizational units, OUs. You can organize accounts into OUs and apply policies at the group level, making it easier to manage large AWS environments. Use cases: centralizing account management for large enterprises. Enforcing security and compliance policies across multiple AWS accounts. Aggregating usage for volume discounts on AWS services. Amazon App Flow. Amazon App Flow is a fully managed service for securely transferring data between SaaS applications like Salesforce, Zendesk, ServiceNow, and AWS services like S3 and Redshift. Features: data encryption. Transfers are encrypted, ensuring data is secure in transit. AWS Private Link Support transfers data privately without traversing the internet. Scheduled or on-demand flows automate the data synchronization process, either on demand or at regular intervals. Sources: SaaS applications, Salesforce, ServiceNow, SAP, Zendesk, Slack, etc. Destinations: AWS services like S3, Redshift, and third-party applications. Use cases: automating data sync between Salesforce and Redshift for reporting. Securely transferring Zendesk ticket data to S3 for archiving. AWS Control Tower. AWS Control Tower helps to manage multi-account AWS environments by setting up a secure and scalable landing zone. It is designed to simplify governance and security for organizations with multiple AWS accounts. Key components: guardrails, policies that ensure accounts comply with organizational governance requirements. These can be preventive, blocking unwanted actions, or detective, monitoring compliance. Account Factory automates the creation of new accounts that adhere to organizational standards, saving time and ensuring consistency. Use cases: automating the setup of AWS environments with predefined security and compliance requirements. Simplifying multi-account management for large enterprises or organizations with many business units. Use case: set up and govern a secure, multi-account AWS environment based on best practices. Example: a startup wants to quickly establish a multi-account environment with baseline security configurations. AWS Control Tower automates the setup, creating accounts for development, testing, and production with predefined guardrails. AWS Proton. AWS Proton is a deployment and change management service for container-based and serverless applications. It is ideal for organizations with development teams that need a self-service platform to deploy their infrastructure as code, IAC, services. Features: templates. Centralized environment and service templates can be defined by platform teams. Developers can then deploy services based on these templates. C/CD integration supports integration with continuous integration and delivery, C/CD pipelines. Infrastructure as code, IAC. Developers use IAC templates, CloudFormation, to deploy and manage resources consistently across environments. Use cases: standardizing the deployment of applications across development, testing, and production environments. Creating a self-service platform for development teams to deploy microservices without managing infrastructure. AWS Compute Optimizer. AWS Compute Optimizer analyzes the usage of your compute resources, like EC2 instances, auto-scaling groups, Lambda functions, and EBS volumes, and makes recommendations to optimize cost and performance. Features: recommendations provides right-sizing recommendations for EC2 instances based on utilization, for example, suggesting smaller instance types if resources are underutilized. Machine learning-based analysis uses machine learning to analyze historical usage patterns and suggest optimal configurations. Use cases: optimizing EC2 instances to reduce costs by selecting the right instance size. Avoiding over-provisioning or under-provisioning of resources by using data-driven recommendations. AWS Trusted Advisor. AWS Trusted Advisor is a tool that helps you optimize your AWS environment by offering real-time guidance on best practices in 5 categories: cost optimization, performance, security, fault tolerance, and service limits. Key areas: cost optimization identifies unused or idle resources, for example, unattached EBS volumes or underutilized EC2 instances. Security suggests best practices, such as enabling MFA on root accounts and identifying exposed security groups. Performance ensures resources are being utilized optimally, for example, matching the right EC2 instance types with your workload. Fault tolerance provides recommendations to increase resilience, for example, enabling multi-as deployments for RDS databases. Service limits monitors your usage against AWS service limits, for example, number of EC2 instances, EBS volumes. Use cases: ongoing AWS environment optimization and cost reduction. Enhancing security and resilience by identifying misconfigurations or unused resources. AWS Direct Connect. AWS Direct Connect is a dedicated, private network connection from your on-premises environment to AWS, bypassing the public internet. This offers more consistent network performance, lower latency, and higher security compared to a typical VPN. Key points: private network, traffic travels over a private line, not the public internet, making it more secure and reliable. Bandwidth supports higher bandwidth options, up to 10 gigabits per second, and provides more predictable performance. Virtual interfaces allows private and public VPC access, connecting to AWS services such as S3 using either private IP addresses, VPC resources, or public IP addresses, S3, CloudFront. Pricing. Charged per gigabyte of data transferred in and out of AWS. You will also incur charges for using multiple virtual interfaces and connections. Setup time. Direct Connect usually takes around a month to set up due to the need for telecommunication services to provision a dedicated connection. Use cases. Companies requiring high throughput and low latency, such as financial services or media companies. Organizations with hybrid cloud strategies needing secure, reliable connections for transferring large amounts of data regularly. Use case. Establish a dedicated network connection from on-premises to AWS, increasing bandwidth throughput and providing a more consistent network experience. Example, a financial institution requires a secure and reliable connection to AWS for data processing. They use AWS Direct Connect to establish a private, high-bandwidth connection that bypasses the public internet. AWS Storage Gateway. AWS Storage Gateway is a hybrid cloud service that provides on-premises applications access to virtually unlimited cloud storage. It connects your on-premises environment to AWS, making it ideal for hybrid cloud use cases such as backup, archive, disaster recovery, and tiered storage. Gateway types. S3 File Gateway. Translates file system protocols, NFS/SMB, to S3 API requests. Caches recently accessed data locally for low latency access while seamlessly storing data in S3 for durability and scalability. Ideal for tiered storage or for applications that natively access file shares but need cloud scalability. FSx File Gateway. Provides access to Amazon FSx for Windows File Server. Supports Windows native protocols, SMB, NTFS, and Active Directory. Caches frequently accessed data locally, making it ideal for workloads that need high-performance file shares and compatibility with Windows. Volume Gateway. Provides block storage via ISCSI, backed by EBS snapshots. Cached volumes store frequently accessed data on premises for low latency access while keeping the full dataset in AWS. Stored volumes. Entire datasets are stored on premises, with scheduled backups to S3 for disaster recovery purposes. Tape Gateway. A virtual tape library, VTL, interface that allows backup applications to write data to AWS as if it were writing to physical tapes. Can archive data directly to S3 Glacier, which offers a low-cost, long-term storage solution. Use cases. Long-term data migration. Data compliance and backup strategies for hybrid cloud architectures. Disaster recovery and tiered storage. Use case. Integrate on-premises IT environments with cloud storage, providing seamless and secure integration between on-premises and AWS storage infrastructure. Example, a media company uses Tape Gateway to replace physical tape infrastructure. Backup software writes data to virtual tapes, which are stored in Amazon S3 and archived in Glacier, reducing costs and retrieval times. AWS Transfer Family. AWS Transfer Family provides fully managed file transfer services, SFTP, FTPS, and FTP, into and out of AWS, enabling the secure exchange of files over traditional file transfer protocols. Features. Managed infrastructure. No need to manage servers or networking infrastructure for file transfers. Authentication options. Supports integration with existing authentication systems like AWS Directory Service, Cognito, ULDAP, or Active Directory. Integration with AWS Storage. Files can be stored in Amazon S3 or Amazon EFS as the backend for file storage. Pricing. Charges per provisioned endpoint per hour, as well as for data transfers, GBs. Use cases: ERP, CRM, or public data exchanges, especially where file transfer protocols, FTP/SFTP/FTPS, are standard. Enterprises needing to securely transfer files to Amazon S3 for further processing or analysis. AWS VPN. AWS VPN provides secure connections between on-premises networks or remote users and AWS resources via the Internet. This is typically used when low setup cost and flexibility are more important than guaranteed network performance, as is the case with Direct Connect. Types of VPNs. AWS Managed VPN provides an IPsec VPN connection over the Internet. AWS manages redundancy and failover across multiple VPN tunnels. Connects to your VPC through a virtual private gateway. AWS VPN Cloud Hub provides a hub-and-spoke VPN model for securely connecting multiple remote branch offices via VPN. Uses BGP for routing between the branches and allows branch-to-branch communication. Software VPN, customer managed. Uses software appliances to create an IPsec VPN connection over the Internet, offering more flexibility for routing and vendor choice. Direct Connect plus VPN combines Direct Connect for high bandwidth with VPN for secure, encrypted connections over the private line. Use cases: securely connecting on-premises networks to AWS VPCs, enabling remote offices to access AWS resources in a hub-and-spoke model. Disaster recovery or backup scenarios. Use case: securely connect on-premises networks or devices to AWS using encrypted VPN tunnels. Example: a company wants remote employees to access resources within a VPC securely. They set up AWS Client VPN to allow employees to establish secure connections to the VPC over the Internet. AWS Application Discovery Service. Application Discovery Service helps in planning migrations to AWS by automatically identifying on-premises applications and their dependencies. This helps build a migration strategy for enterprise-scale workloads. Discovery types. Agent-based discovery requires installing an agent on each on-premises server. Collects system performance metrics, running processes, and network connections. Agentless discovery. No installation required. Provides basic information such as VM inventory, configuration, and performance history from VMware environments. Use cases: gathering performance and inventory data for planning application migration to AWS. Identifying application dependencies and building a migration roadmap. AWS Database Migration Service, DMS. AWS DMS helps migrate databases to AWS with minimal downtime. It supports both homogeneous migrations, for example, Oracle to Oracle, and heterogeneous migrations, for example, Oracle to MySQL. Key features: continuous replication, supports continuous data replication from the source database to the target database during migration. Schema conversion tool, when migrating between different database engines, the schema conversion tool can help transform and migrate schemas and stored procedures. Resilient and self-healing, if the connection is interrupted, DMS automatically recovers and resumes the migration. Sources: on-premises databases, EC2 instances, Azure, S3, RDS, Aurora. Targets: relational databases, OpenSearch, DynamoDB, Redshift, DocumentDB, or S3. Use cases: migrating relational databases to AWS services such as Aurora, RDS, or DynamoDB. Replicating databases between on-premises and AWS to ensure data continuity. Use case: migrate databases to AWS quickly and securely with minimal downtime. Example: a company wants to migrate an on-premises Oracle database to Amazon Aurora PostgreSQL. Using DMS, they perform a homogeneous migration, replicating data changes during the migration to minimize downtime. AWS Data Sync AWS Data Sync automates and accelerates the process of moving large amounts of data between on-premises storage and AWS services such as S3, AFS, or FSx. Key features: encryption. Data is encrypted in transit and can be moved securely over the internet or direct connect. High throughput, optimized to handle large-scale data transfers much faster than traditional methods like sync. Use cases: one-time data migrations, ongoing replication, or disaster recovery backups. Moving large datasets to S3, AFS, FSx from on-premises or other clouds. Use case: simplify and automate data transfer between on-premises storage and AWS storage services. Example: a research organization needs to move petabytes of data from on-premises NAS devices to Amazon S3 for analysis. AWS Data Sync automates the transfer, ensuring data integrity and optimizing transfer speeds. AWS Snow Family. The AWS Snow family provides physical devices designed to move large amounts of data to or from AWS or to process data at the edge, especially in disconnected environments. Snow devices. Snowball Edge provides storage and compute capabilities, EC2 and Lambda functions. Available in storage-optimized 80 terabytes and compute-optimized variants. Ideal for moving terabytes to petabytes of data when bandwidth is insufficient. Snowcone. A small, portable device with 8 terabytes of storage. Can also be used for edge computing in environments with limited space or intermittent connectivity. Snowmobile. A 100 petabytes capacity truck used to move extremely large datasets, over 10 petabytes. High security measures and tracking make it ideal for large-scale migrations. Use cases: data migration, moving massive datasets when network connections are too slow or unreliable. Edge computing, processing data in disconnected environments, for example, field research, remote industries. AWS Application Migration Service, MGN. AWS MGN is a fully managed service that simplifies the migration of on-premises applications to AWS by continuously replicating the source servers into AWS. It performs rehosting, also called lift and shift, of applications. Key features: agent-based replication, installs an agent on source servers to replicate data and applications into AWS. Minimal downtime. After initial replication, ongoing changes are continually replicated, ensuring minimal downtime during cutover. Supports multiple platforms, can migrate applications running on various platforms and operating systems. Use cases: migrating enterprise applications that need to remain largely unchanged, rehosting. Message queue, RabbitMQ or ActiveMQ. RabbitMQ and ActiveMQ are popular open-source message brokers that can be used for decoupling applications and ensuring reliable message delivery between services. Key features: topics and queues, offer support for both message queue, similar to SQS, and message topic patterns, similar to SNS, allowing more flexible architectures. High availability, multi-as configurations are available to ensure failover and high availability. EFS for failover. In the case of failover, Amazon EFS is used to store persistent message queue data. Use cases: migrating legacy applications to AWS without modifying their message queuing functionality. Reliable messaging across distributed systems in hybrid environments. Amazon Managed Streaming for Apache Kafka, MSK. Amazon MSK is a fully managed service that makes it easy to build and run applications using Apache Kafka on AWS. Key features: MSK Serverless automatically scales to match your application's throughput without requiring provisioning. Message limits: Apache Kafka allows up to 10 megabytes per message, while Kinesis limits message size to 1 megabyte. Cluster: fully managed Kafka clusters with built-in redundancy and failover. Difference to Kinesis: message size: Kafka allows for larger messages, up to 10 megabytes, compared to Kinesis's 1 megabyte limit. Partitions: Kafka uses partitions within topics, whereas Kinesis uses shards. Scaling. Kafka scales by adding partitions to topics. Kinesis scales by adding shards. Security. Kafka does not enforce SSL by default, whereas Kinesis requires SSL. Consumers. Applications on EC2, ECS, EKS. AWS services like Kinesis Data Analytics, AWS Glue, and Lambda. Amazon Pinpoint. Amazon Pinpoint is a scalable marketing communication service for sending personalized messages via SMS, push notifications, email, and voice messages. Key features. Personalized messages allows personalization and targeting of messages to specific customer segments. Receive replies can handle replies to SMS messages for two-way communication. High throughput, capable of scaling to billions of messages per day. Use cases. Marketing campaigns and transactional messaging. Personalized notifications to customers based on user behavior. Sending messages via different channels such as SMS, push notifications, email, or voice. Difference from SNS and SES. Pinpoint handles templates, scheduling, and campaigns for marketing communications. SNS and SES require applications to manage these processes manually. Amazon Simple Email Service, SES. Amazon SES is a fully managed email service for sending and receiving email using your applications. Key features. Inbound and outbound, supports both sending and receiving emails. Anti-spam, built-in anti-spam mechanisms to ensure the deliverability of emails. Authentication, supports DKIM, domain keys identified mail, and SPF, sender policy framework, for email authentication. Flexible IP deployment, allows for the use of shared or dedicated IP addresses. Sending methods. Can send emails via SMTP, console, or API. Use cases. Sending transactional emails, for example, receipts, notifications. Marketing emails with built-in tracking and deliverability tools. Receiving emails for applications like customer support. Amazon Simple Notification Service, SNS. Amazon SNS is a fully managed publish/subscribe messaging service that can send messages to multiple subscribers at once. Key features. Asynchronous model, a single producer can send a message to multiple subscribers. Scalability, can handle millions of messages per second. Filtering, subscribers can filter messages based on JSON policies, receiving only the relevant messages. Use cases. Sending alerts or notifications to multiple services. Implementing a pub/sub architecture for distributing events across systems. Security. Encryption, messages can be encrypted at rest using KMS. Access control, permissions can be controlled through IAM roles and resource-based policies. Use case, send time-critical messages to multiple subscribers via push-based delivery. Example, a stock trading platform uses SNS to send real-time price alerts to subscribers via SMS, email, or mobile push notifications, ensuring timely delivery of critical information. Amazon Simple Queue Service, SQS. Amazon SQS is a fully managed message queue service that allows you to decouple systems and process tasks asynchronously. Key features. Unlimited throughput, can handle an unlimited number of messages and requests per second. Visibility timeout, messages are invisible to other consumers after being polled until they are processed or the timeout expires. FIFO, guarantees that messages are processed in the exact order they are sent and ensures that messages are delivered exactly once. Use cases. Decoupling microservices to improve scalability and resilience. Processing long-running tasks asynchronously. Security. Encryption, messages can be encrypted using KMS. Access control, uses IAM roles and policies to control access to queues. Use case, decouple and scale microservices, distributed systems, and serverless applications using message queues. Example: an e-commerce application uses SQS to manage order processing. Orders placed on the website are sent to an SQS queue, where back-end systems retrieve and process them asynchronously, improving reliability and scalability. Amazon Event Bridge. Event bus for integrating AWS services and custom applications. A serverless event bus that allows decoupling through event-driven communication. It supports integration with AWS services and external applications. Use case: build event-driven architectures by connecting applications using data from your own apps, integrated SaaS applications, and AWS services. Example: a ticketing system publishes events when new tickets are created. Event Bridge routes these events to Lambda functions that process the tickets, update databases, and send notifications, all without custom polling or scheduling code. Design scalable and loosely coupled architectures. Scalable and loosely coupled components. Multi-tier architectures. Presentation layer handles user interaction, for example, ELB, CloudFront. Application layer processes data, for example, EC2 instances, Lambda functions. Data layer stores data, for example, RDS, DynamoDB. Decoupling with messaging services. Amazon SQS. Description: fully managed message queuing service. Use case: decouple components, buffer requests. Amazon SNS. Description: pub/sub messaging service. Use case: fan out messages to multiple subscribers. Amazon Event Bridge. Description: event bus for integrating AWS services and custom applications. Example use case. Scenario: an e-commerce application needs to process orders without overloading the back-end. Solution: use SQS queues, place orders in a queue to be processed asynchronously. Use Lambda functions, triggered by SQS to process orders. Microservices and serverless architectures. Design principles. Statelessness: services do not store session information. Independent scaling: each microservice can scale independently. Loose coupling: services interact through well-defined APIs. AWS services. AWS Lambda: run code without provisioning servers. AWS Fargate: run containers without managing servers. API Gateway: create and manage APIs for back-end services. AWS Step Functions coordinates microservices and serverless functions into workflows, enabling complex, stateful application workflows without managing infrastructure. Example use case. Scenario: developing a scalable web application where different functionalities, user service, product service, need to scale independently. Solution: use microservices architecture, separate functionalities into independent services. Deploy on AWS Lambda or Fargate for serverless execution. Use API Gateway as a front door for all API requests. Containers and orchestration. AWS services. Amazon ECS, Elastic Container Service. Description: container orchestration service that supports Docker containers. Launch types. EC2, you manage the EC2 instances. Fargate, AWS manages the infrastructure. Amazon EKS, Elastic Kubernetes Service. Description: managed Kubernetes service. Use case: when Kubernetes is preferred for container orchestration. Example use case. Scenario: migrating an existing containerized application to AWS with minimal changes. Solution: use Amazon ECS with Fargate launch type for simplified management. Alternatively, use Amazon EKS if Kubernetes expertise exists. Kubernetes. Use case: run and manage Docker containers on a scalable cluster. Example: a web application is broken down into microservices, each running in its own Docker container. Amazon ECS orchestrates these containers across a cluster of EC2 instances, handling scheduling and scaling. Use case: run Kubernetes on AWS without needing to install, operate and maintain Kubernetes control planes. Example: a company already using Kubernetes on premises wants to migrate to AWS. Using Amazon EKS, they can leverage their existing Kubernetes expertise to manage containers in the cloud. Caching strategies. AWS services. Amazon Elastic, Cache. Engines, Redis and Memcached. Use cases: caching frequently accessed data, session storage. Amazon CloudFront. Description: Content Delivery Network, CDN. Use cases: serve static and dynamic content with low latency. Example use case. Scenario: a news website needs to deliver content quickly to users worldwide. Solution: use CloudFront, cache content at edge locations globally. Implement Elastic Cache database queries to reduce load. AWS Simple Workflow, SWF. Amazon Swift is a fully managed service for coordinating tasks across distributed systems. It allows you to build stateful workflows, track job progress, and manage task assignments. Key features: Task Coordinator coordinates and tracks tasks in a distributed system. Stateful Workflows keeps track of the state of each task, allowing retries and timeouts. Use cases: orchestrating multi-step processes that involve long-running tasks. Decoupling systems while keeping track of the state and progress of workflows. AWS Global Accelerator. AWS Global Accelerator is a service that improves the availability and performance of your applications by routing traffic through AWS's global network. Key features: Global Anycast IPs provides two static Anycast IP addresses as entry points, simplifying traffic routing. High availability automatically routes traffic to healthy endpoints across multiple regions. Health checks continuously checks the health of your endpoints and routes traffic to the optimal one. Use cases: applications requiring low latency global access. Disaster recovery solutions where traffic needs to be redirected quickly during outages. Use case: improve availability and performance of applications for local and global users by directing traffic through the AWS global network. Example: an online multiplayer game requires low latency connections for players around the world. AWS Global Accelerator routes user traffic to the optimal AWS endpoint, reducing latency and jitter. NAT Gateway. NAT Gateway allows instances in a private subnet to access the internet while preventing the internet from initiating connections to the instances. Key features: AWS Managed. NAT Gateway is a fully managed service that automatically scales to handle your traffic. High availability. NAT Gateway is designed to be highly available within a single availability zone. Use cases: allowing private instances in a VPC to access the internet for software updates or external services. Avoiding the need to manage NAT instances manually. Amazon Route 53. Amazon Route 53 is a scalable and highly available DNS, domain name system, web service. It can be used for domain registration, DNS management, and health checking. Key features: DNS resolution translates domain names into IP addresses. Routing policies supports multiple routing policies, for example, latency-based routing, weighted routing, geolocation routing. Health checks. Route 53 can automatically remove unhealthy endpoints from the routing pool based on health check results. Use cases: hosting DNS for websites and services. Configuring global traffic routing and load balancing with health checks. Use case: provide highly available and scalable domain name system, DNS, web service. Example: a global application uses Route 53 for DNS management, leveraging health checks and latency-based routing to direct users to the nearest healthy endpoint, improving performance and reliability. Amazon VPC, Virtual Private Cloud. Amazon VPC provides logically isolated cloud resources with customizable networking configurations. It allows you to define your own IP address range, subnets, route tables, and internet gateways. Key features: public and private subnets, You can create subnets that are publicly accessible, public subnets, or private subnets, with no direct internet access. VPC peering allows VPCs to communicate with each other using private IP addresses. VPC endpoints, private connections to AWS services such as S3 and DynamoDB without going over the internet. AWS Transit Gateway simplifies VPC to VPC communication by acting as a central router for multiple VPCs or on-premises networks. Use cases: creating isolated cloud environments with secure networking, connecting on-premises networks to AWS using VPN or Direct Connect. Amazon Guard Duty. Amazon Guard Duty is an intelligent threat detection service that continuously monitors your AWS accounts and workloads for malicious activity. Features: threat detection uses machine learning, ML, to analyze AWS data sources and detect suspicious activity such as unauthorized access or data exfiltration. Continuous monitoring monitors data stored in S3, AWS CloudTrail events, and VPC traffic for unusual behavior. Crypto mining detection detects and prevents cryptocurrency mining attacks on your infrastructure. Sources to analyze: CloudTrail management events, CloudTrail S3 data events, VPC flow logs, DNS logs, EKS audit logs. Findings: Guard Duty generates findings that can trigger CloudWatch events, which can be forwarded to Lambda or SNS for remediation. Disabling Guard Duty resets the service and deletes all the data it has collected. Use case: continuously monitor for malicious or unauthorized behavior to protect AWS accounts and workloads. Example: Guard Duty detects unusual API calls and alerts the security team when an EC2 instance is making API requests to known malicious IP addresses, indicating a potential compromise. Cloud Hardware Security Module, HSM. Cloud HSM is a hardware-based security module used to store cryptographic keys and perform secure cryptographic operations. Key features: FIPS 142 Level 3 compliant. Can integrate with KMS for secure key management. Exportable keys. Keys can be exported to other HSMs for integration with existing security infrastructures. Use cases: key security. Cryptographic keys are securely stored and handled in the HSM. Disaster recovery. Use multi-as deployments to avoid key loss. If the device is wiped, data cannot be recovered. AWS Inspector. AWS Inspector is an automated security assessment service that helps to improve the security and compliance of applications deployed on AWS. Key features: continuous scanning, automatically scans for vulnerabilities and network reachability. Vulnerability detection, analyzes installed packages and compares them with known vulnerabilities. Risk scores, generates risk scores based on network accessibility and the severity of vulnerabilities. Supported resources: EC2 instances, scans for vulnerabilities and misconfigurations. Containers in ECR, scans for vulnerabilities when a container image is pushed to ECR. Integration: AWS Security Hub, findings can be centralized in Security Hub. Amazon Event Bridge, automatically trigger remediation workflows based on findings. Determine appropriate data security controls. Data access and governance. Data classification. Process, identify and categorize data based on sensitivity, for example, public, confidential, secret. Purpose, apply appropriate security controls. Policies for data access. S3 bucket policies, control access at the bucket level. IAM policies, grant permissions to users, groups, roles. Encryption policies, enforce encryption for data at rest and in transit. Example use case. Scenario: an organization needs to ensure that sensitive data stored in S3 is encrypted and only accessible by specific roles. Solution: S3 bucket policies restrict access to specific IAM roles. Enforce encryption. Require that all objects uploaded must be encrypted. AWS Key Management Service, KMS. AWS KMS is a managed service that enables you to create and control cryptographic keys across your AWS resources. Key features. Key types. Symmetric keys, single key used for encryption and decryption, for example, ICE-256. Asymmetric keys, public key for encryption, private key for decryption. FIPS 140-2 validated, meets security standards for government and regulated industries. Automatic key rotation, AWS managed keys are rotated every year automatically. Integration, works with many AWS services. Policies, control access to keys. Encryption at rest. EBS volumes, enable encryption when creating volumes. RDS databases, enable encryption at database creation. S3 objects, use server-side encryption, SSE-KMS, SSE-S3, or client-side encryption. Use cases. EBS encryption, KMS is used for encrypting EBS volumes. Auditability, logs all key usage in CloudTrail. Pricing. 3 cents per 10,000 API calls. Multi-region keys. Keys are replicated across regions for global encryption/decryption use cases, for example, Aurora Global, DynamoDB Global Tables. Use case, create and manage cryptographic keys and control their use across AWS services and applications. Example, an application stores sensitive customer data in Amazon S3 and encrypts it using AWS KMS managed keys. This ensures that data is protected at rest and access to encryption keys is controlled and auditable. AWS Certificate Manager, ACM. Features. Provision certificates, SSL/TLS certificates for AWS services. Automatic renewal, manages certificate expiration. Encryption in transit. Use cases, encrypt data between clients and servers, HTTPS. Example use case. Scenario, a web application needs to ensure data is encrypted in transit and at rest, with strict control over who can decrypt the data. Solution. Data at rest, use SSE-KMS for S3 buckets, encrypt EBS volumes, enable RDS encryption. Data in transit, use ACM to provision SSL/TLS certificates for ELBs. Key policies, restrict key access to specific IAM roles. Implementing data backups and replications. AWS Backup. Features. Centralized backup management, schedule backups for various AWS services. Cross-region and cross-account backups, enhance disaster recovery capabilities. Replication. S3 cross-region replication, CRR. Use case, replicate data across regions for compliance or latency purposes. RDS read replicas. Use case, create read replicas in different regions. Example use case. Scenario, a company requires offsite backups of critical data for disaster recovery. Solution. Use AWS Backup, schedule backups to a different region. Implement CRR for S3, automatically replicate objects to a backup bucket in another region. Rotating encryption keys and renewing certificates. Key rotation. AWS KMS automatic rotation. Features, rotate keys annually. Manual rotation. Process, create new keys and update applications to use them. Certificate renewal. ACM managed certificates. Automatic renewal, ACM handles renewal and deployment. Importing certificates. Responsibility, manage the renewal process manually. Example use case, scenario, ensure compliance by rotating encryption keys and renewing certificates regularly. Solution, enable automatic key rotation in KMS for keys that support it. Use ACM certificates for services like ELB to benefit from automatic renewal. Amazon Macy. Amazon Macie is a fully managed data security and privacy service that uses machine learning to discover, classify, and protect sensitive data stored in S3. Key features: ML-based detection identifies personally identifiable information, PII, such as social security numbers, credit card numbers, etc. Continuous monitoring continuously monitors S3 buckets for sensitive data and security vulnerabilities. Use case: discover and protect sensitive data stored in Amazon S3 using machine learning to recognize sensitive content. Example: a healthcare provider uses Macie to scan S3 buckets for protected health information, PHI. Macie alerts them to any unencrypted or publicly accessible data containing sensitive information. AWS Network Firewall. AWS Network Firewall is a managed firewall service for VPCs designed to protect cloud resources from network threats. Key features: stateful inspection includes protocol filtering and intrusion prevention. Domain filtering allows traffic filtering based on domain names, for example, only allow access to example.com. Active flow inspection inspects live traffic for malicious behavior. Logging: send logs to S3, CloudWatch logs, or Kinesis Firehose. AWS Systems Manager Parameter Store. Parameter Store is a secure storage service for configuration data and secrets, for example, database passwords, API keys. Key features: versioning, track and manage multiple versions of parameters. KMS encryption, parameters can be encrypted with KMS for additional security. Cost: standard, free for up to 10,000 parameters, max size 4 kilobytes. Advanced, supports up to 100,000 parameters, max size 8 kilobytes, includes policies for TTL and notifications. AWS Security Token Service, STS. AWS STS provides temporary security credentials to users, applications, or services for accessing AWS resources securely. These credentials work similarly to long-term access keys but expire after a predefined period. Use cases: temporary access to AWS resources for users or federated roles. Used in cross-account access scenarios and federated access. AWS Secrets Manager. AWS Secrets Manager is a service that helps manage and rotate secrets, for example, database credentials, API keys, securely. Key features: automatic rotation, can automatically rotate secrets based on a schedule. Multi-region secrets, supports replication of secrets across regions for disaster recovery. Use cases: RDS integration, Secrets Manager integrates with RDS to rotate database credentials automatically. Difference from Parameter Store. Secrets Manager is designed specifically for secrets management and requires rotation of secrets, whereas Parameter Store is more generalized and can store both configuration data and secrets. Use case: protect secrets needed to access applications, services, and IT resources. Example: a microservices application needs database credentials to connect to an RDS instance. Using AWS Secrets Manager, the application retrieves credentials securely, and Secrets Manager rotates them automatically, enhancing security. Security groups. SG security groups act as virtual firewalls for your EC2 instances, controlling inbound and outbound traffic. Key features: stateful. If an inbound rule allows traffic, the response is automatically allowed outbound. IP or SG referencing. You can reference an IP range or another SG for inbound/outbound rules. Use cases: limiting access to instances based on IP ranges or specific ports, for example, SSH access on port 22. Troubleshooting: timeout errors, usually caused by misconfigured security group rules. Connection refused, application or server issues, not related to SG. AWS Web Application Firewall, WAF. AWS WAF is a service that helps protect web applications from Layer 7 attacks, such as SQL injection or cross-site scripting, XSS. Deploy targets. ALB API Gateway, CloudFront, Cognito User Pools, Rules, Geo-matching, allow or block requests from specific countries. Rate-based rules limits the number of requests from a single IP address. Use case, protect web applications from common web exploits that affect availability, compromise security, or consume excessive resources. Example, a financial services company uses AWS Wave to block SQL injection and cross-site scripting attacks on their application hosted behind an application load balancer. Amazon Aurora. Amazon Aurora is a MySQL and PostgreSQL compatible relational database engine designed for performance and availability. Key features: auto-scaling. Aurora automatically scales up to 64 terabytes of storage. High performance, 5x faster than MySQL and 3x faster than PostgreSQL. Global clusters, supports Global Aurora for multi-region read/write replication with replication latency under 1 second. Aurora Serverless. Automatically scales based on demand, making it ideal for unpredictable workloads. Backups. Automated backups can be retained for 1 to 35 days with point-in-time recovery, PITR. Amazon Document DB. Amazon Document DB is a fully managed document database service that is MongoDB compatible. Key features: automatic scaling. Storage scales automatically up to 64 terabytes. Multi-as replication, replicates data across 3 availability zones. Use cases: applications that use MongoDB but want the scalability and reliability of AWS services. Amazon DynamoDB. Amazon DynamoDB is a fully managed NoSQL database service that provides fast and predictable performance with seamless scalability. Key features: serverless, no need to manage infrastructure, with millisecond latency at any scale. Capacity modes, provisioned capacity with optional auto-scaling or on-demand capacity. Global tables, allows multi-region, multi-master replication for globally distributed applications. Use cases: session data, caching, gaming, and IoT applications. Amazon Elastic Block Store, EBS. Amazon EBS is durable, block-level storage that can be attached to EC2 instances. Key features: persistent storage. EBS persists even after the instance is terminated, if not configured for deletion. Snapshots, create incremental backups that can be stored across regions. Volume types: GP3, GP2, general purpose SSD volumes, cost-effective for most workloads. IO1, IO2, high-performance SSD volumes for mission-critical applications. SD1, SC1, low-cost HDD volumes for large datasets with infrequent access. Amazon Elastic File System, EFS. Amazon EFS is a fully managed, scalable network file system for use with AWS cloud services and on-premises resources. Key features: multi-as, highly available and scalable across multiple ASes. Storage classes, supports standard and infrequent access, IA, tiers for cost optimization. Performance modes: general purpose, low latency workloads. Max I/O, higher throughput for big data and media processing. Use case: provides scalable file storage for use with AWS cloud services and on-premises resources. Example, a media processing company needs shared storage accessible by multiple EC2 instances for rendering video files. They use Amazon EFS to provide a common file system that scales automatically as data grows. Amazon Elastic Cache. Amazon Elastic Cache provides in-memory caching services using Redis or Memcached to accelerate the performance of applications. Key features: Redis supports replication, persistence, and high availability with failover. Memcached, a simpler, distributed memory object caching system that doesn't support replication or high availability. Use case: deploy, operate, and scale an in-memory data store or cache in the cloud to improve application performance. Example, a social media platform, uses Elastic Cache for Redis to cache frequently accessed user profiles, reducing the load on the primary database and providing faster response times. Amazon FSx for Lustre and Windows. Amazon FSx for Lustre, a fully managed high-performance file system for compute-intensive workloads such as machine learning, video processing, and financial modeling. It integrates with S3 for cold storage and provides low-latency access for active datasets. Amazon FSx for Windows File Server, a fully managed file system built on SMB protocol with integration into Active Directory. Ideal for Windows-based workloads. Amazon EC2 Instance Store. EC2 Instance Store is temporary, ephemeral storage that is physically attached to an EC2 instance. Key features: high IOPS, high performance, low latency storage, ideal for temporary data like buffers or caches. Ephemeral, data is lost if the instance is stopped or terminated. Amazon Keyspaces. Amazon Keyspaces is a fully managed Apache Cassandra-compatible database service. Key features: serverless, automatically scales to meet your application's throughput requirements. CQL support, use the Cassandra Query Language, CQL, to interact with the database. Use cases: storing IoT data, time series data, and other high-throughput workloads. AWS Lake Formation. AWS Lake Formation simplifies the process of setting up a secure data lake for storing and analyzing vast amounts of data. Key features: data centralization, allows you to store structured and unstructured data in S3, making it accessible to multiple analytics services. Fine-grained access, enables column-level security for data stored in the data lake. Amazon Open Search. Amazon Open Search is a managed service for search and analytics use cases. Key features: full text search, optimized for searching and analyzing large datasets. Real-time analytics, integrates well with Kinesis and Lambda for real-time data ingestion. Amazon Quantum Ledger Database, QLDB. Amazon QLDB is a fully managed ledger database that provides a transparent, immutable, and cryptographically verifiable transaction log. Key features: immutable transactions, records are immutable, preventing modifications once they are written. Cryptographic verification, provides an audit trail to verify the integrity of the transaction history. Amazon RDS. Amazon RDS is a managed relational database service that supports multiple database engines, including MySQL, PostgreSQL, Oracle, and SQL Server. Key features: multi-as, provides automatic failover in the event of hardware failure. Read replicas, can create up to 5 read replicas for horizontal scaling. Use case, set up, operate, and scale a relational database in the cloud with ease. Example: a financial application requires a highly available PostgreSQL database. Using Amazon RDS with multi-as deployment, the database automatically fails over to a standby replica in case of a primary instance failure, minimizing downtime. Amazon Redis. Amazon Redis is a fully managed, in-memory data store that provides high performance, sub-millisecond latency, and scalability. Key features: multi-as with failover, provides replication and automatic failover. In-memory caching, reduces the load on relational databases by providing a caching layer. Amazon Redshift. Amazon Redshift is a fully managed data warehouse that allows you to run complex queries against petabyte-scale data. Key features: massive parallel processing, MPP. Redshift is designed to handle large-scale data analytics workloads. Redshift Spectrum, query data directly in S3 without moving it into Redshift. Use cases: data warehousing for business intelligence, reporting, and data analysis. Amazon S3, simple storage service. Amazon S3 is an object-based storage service that allows users to store and retrieve any amount of data at any time. Key features: max object size, 5 terabytes per object. Multi-part upload, For objects larger than 5 gigabytes, multi-part upload is recommended to ensure efficient transfer. It allows large objects to be uploaded in parts. Storage tiers. S3 supports multiple storage classes such as Standard, Infrequent Access, IA, Glacier, and Glacier Deep Archive to optimize costs based on access patterns. Requester pays. In this model, the requester, downloader, pays for the download and network costs instead of the bucket owner. Useful for sharing large datasets across accounts. S3 event notifications can trigger actions like invoking a Lambda function when objects are uploaded or modified in a bucket. Targets, Lambda, SNS, SQS, may take up to a minute to trigger an action. S3 access logs. Access logging logs detailed information about the requests made to your bucket for security and access audits. Versioning. Object versioning. When enabled, previous versions of an object are retained, even when a new version is uploaded or when an object is deleted. Delete marker, a placeholder that marks the deletion of an object but retains older versions. Storage tiers. Standard, general-purpose storage for frequently accessed data. Infrequent access, IA, cheaper, suitable for data accessed less frequently, but instantly available. Glacier, low-cost storage for archival data that doesn't require real-time access. Retrieval times range from a few minutes, expedited, to several hours, bulk. Use case, archive infrequently accessed data at a low cost with high durability. Example, a legal firm must retain client records for several years but rarely accesses them. They store these records in S3 Glacier, significantly reducing storage costs while meeting compliance requirements. Glacier Deep Archive, 75% cheaper than Glacier but with longer retrieval times, up to 48 hours. Transfer Accelerator. Faster uploads, uses CloudFront edge locations to optimize transfers over long distances. Ideal for large uploads. Bucket policies and ACLs. Bucket policies, JSON-based policies that specify permissions for entire buckets or objects within buckets. Access control lists, ACLs, can be used to grant granular permissions to specific AWS accounts or predefined groups. Encryption. SSE-S3, server-side encryption with Amazon S3 managed keys. SSE-KMS, server-side encryption using AWS KMS for more control over keys. Client-side encryption, you encrypt the data before uploading it to S3. Replication. Cross-region or same-region replication requires versioning to be enabled on both source and destination buckets. Ensures data is replicated for disaster recovery or compliance. Performance. S3 supports up to 3,500 put/copy/post/delete requests per second and 5,500 get/head requests per second, per partition. Use case, store and retrieve any amount of data at any time, from anywhere on the web. Example, a photo-sharing application stores user-uploaded images in Amazon S3. By leveraging S3's scalability and durability, the app can handle millions of users and petabytes of data without worrying about infrastructure management. Amazon TimeStream. Amazon TimeStream is a fully managed, serverless time series database service for storing and analyzing trillions of time series events. Key features. SQL compatibility. TimeStream supports full SQL queries, allowing complex queries over time series data. Storage tiers automatically moves older data to a cheaper storage tier while keeping recent data in memory for fast access. Use cases. IoT applications, collecting and analyzing time series data from sensors and devices. Operational applications, monitoring logs and metrics for cloud infrastructure and applications. Real-time analytics, dashboards for tracking metrics in real time. Integration. Sources, Lambda, AWS IoT, Kinesis Data Analytics, Prometheus, third-party metrics collection. Targets, QuickSight, SageMaker, Grafana, and any JDBC-compliant database. AWS Certificate Manager, ACM. AWS Certificate Manager, ACM, simplifies the process of provisioning, managing, and deploying SSL/TLS certificates for use with AWS services. Key features: automatic renewal. Certificates issued by ACM are automatically renewed before they expire. Supported services, works with elastic load balancers, ELBs, CloudFront, and API gateway to enable HTTPS on your applications. IAM Certificate Store. Used to store and manage certificates in regions where ACM is not available. Use case, provision, manage, and deploy SSL/TLS certificates for use with AWS services and internal connected resources. Example, a company uses ACM to issue and automatically renew SSL certificates for their websites hosted on Amazon CloudFront and elastic load balancing, ensuring secure HTTPS connections without manual intervention. AWS Config. AWS Config is a service that enables you to assess, audit, and evaluate the configurations of your AWS resources. Key features: continuous monitoring, tracks configuration changes and the relationship between AWS resources over time. Compliance allows you to define compliance rules and trigger notifications if resources fall out of compliance. Use cases: audits, useful for audits and regulatory compliance by providing a historical view of resource configurations. Integration. Notifications, send compliance alerts to SNS. Use case, assess, audit, and evaluate the configurations of AWS resources to ensure compliance and security. Example, an enterprise must comply with regulations requiring that all EBS volumes are encrypted. AWS Config monitors EBS volume configurations and alerts the team if any unencrypted volumes are detected. Amazon Athena. Amazon Athena is an interactive, serverless query service that allows you to analyze data in S3 using standard SQL. Key features: serverless, no need to manage infrastructure, you only pay per query. Supported formats, works with various data formats, including CSV, JSON, ORC, Avro, and Parquet. Query partition data in S3 for faster queries. Use cases: log analysis, quickly analyze logs stored in S3. Ad hoc queries, perform ad hoc queries on large datasets without setting up complex infrastructure. Design highly available and/or fault-tolerant architectures. AWS Global Infrastructure. Regions and availability zones, ASes. Region, a physical location with multiple ASes. Availability zone, one or more discrete data centers with redundant power and networking. Design principles. Deploy across multiple ASes, increases availability and fault tolerance. Global services, some services like IAM and Route 53 are global. Example use case. Scenario, an application requires high availability with minimal downtime. Solution. Deploy EC2 instances in multiple ASes, use an ELB to distribute traffic. Use RDS multi as deployments for database high availability. Load balancing. Elastic load balancing, ALB. Types. Application load balancer, ALB, operates at layer 7, supports HTTP/HTTPS. Network load balancer, NLB, operates at layer 4, handles TCP/UDP. Gateway load balancer, GLB, integrates third-party virtual appliances. Features. Health checks, monitors the health of targets. Sticky sessions, binds a user's session to a specific target. SSL termination, offloads SSL processing. Example use case. Scenario, a web application needs to distribute traffic efficiently and handle SSL termination. Solution. Use an ALB, distribute HTTP/HTTPS traffic, handle SSL termination. Configure health checks, ensure only healthy instances receive traffic. Use case, automatically distribute incoming application traffic across multiple targets to increase the availability and fault tolerance of applications. Example, an application running on multiple EC2 instances uses an application load balancer to distribute HTTP requests evenly, ensuring no single instance is overloaded and improving overall performance. Disaster recovery strategies. Options: backup and restore. Description: backup data and restore it when needed. RPO/RTO, high RPO and RTO. Cost: lowest. Pilot light. Description: maintain core components in a minimal fashion. RPO/RTO, lower than backup and restore. Cost: moderate. Warm standby. Description: scaled down version of the production environment. RPO/RTO, even lower. Cost: higher due to running resources. Multi-site, active. Description: full production environment running in multiple regions. RPO/RTO, near zero. Cost: highest. Example use case. Scenario: a financial services application cannot tolerate any downtime. Solution: implement active DR strategy, deploy the application in multiple regions with data replication. Use Route 53 with health checks, automatically route traffic to healthy regions, eliminating single points of failure. Strategies: redundancy, duplicate critical components, for example, multiple EC2 instances. Stateless applications, store session data externally. Auto-scaling, automatically replace failed instances. Example use case. Scenario: an application relies on a single EC2 instance serving as a web server. Solution: deploy multiple EC2 instances across different ASs. Use an ELB, distribute traffic. Implement auto-scaling, replace instances if they fail. AWS Backup. AWS Backup is a centralized service for managing backups across multiple AWS services. Key features: centralized management, manage and automate backup processes across services like EC2, EBS, RDS, S3, DynamoDB, EFS, and Storage Gateway. Cross-region and cross-account backups provides disaster recovery capabilities by enabling cross-region and cross-account backups. Vault Lock ensures that backups cannot be deleted once they are locked, providing extra protection for compliance. Use case: centralize and automate data backup across AWS services to ensure data protection and compliance. Example: a company sets up AWS Backup to schedule regular backups of EFS file systems, RDS databases, and EBS volumes, storing backups in a different region for disaster recovery purposes. AWS Cloud Trail. AWS Cloud Trail tracks and logs all API calls made within your AWS account, providing governance, compliance, and operational auditing. Key features: management events, captures control plane operations like creating, modifying, or deleting resources. Data events, captures object-level operations on services like S3 and Lambda. Cloud Trail Insights, uses machine learning to detect unusual activity in write events. Retention. By default, logs are retained for 90 days, but you can export them to S3 for longer retention. Amazon Cloud Watch. Amazon Cloud Watch is a monitoring service that provides visibility into AWS resources and applications through logs and metrics. Key features: alarms, set alarms based on metric thresholds to trigger actions such as SNS notifications or automatically stopping, terminating, or recovering EC2 instances. Logs, store logs from various AWS services such as Lambda, VPC Flow Logs, API Gateway, and Cloud Trail. Metrics, collect system-level metrics such as CPU, memory, and disk I/O. CloudWatch Agent. Unified Agent, collects both logs and system-level metrics such as CPU, memory, and disk usage. Use case, monitor AWS resources and applications, collect and track metrics, collect and monitor log files, and set alarms. Example, an application monitors CPU utilization of EC2 instances using CloudWatch. If CPU usage exceeds 80%, an alarm triggers an auto-scaling policy to launch additional instances, ensuring application performance. AWS Cloud Formation. AWS Cloud Formation enables you to provision infrastructure as code, IAC, by defining resources in JSON or YAML templates. Key features: Infrastructure as code, IAC, automate the creation and management of AWS resources. Stack sets, deploy CloudFormation stacks across multiple AWS accounts and regions. Creation policies. Creation policy ensures resources like EC2 instances are fully operational before moving to the next step in a stack creation. Use case, model and provision AWS resources using templates to automate infrastructure deployment. Example, a development team uses CloudFormation templates to consistently deploy staging and production environments. This ensures that environments are identical, reducing configuration drift and deployment errors. Amazon CloudFront. Amazon CloudFront is a content delivery network, CDN, service that delivers data, videos, and applications globally with low latency. Key features: Origins. CloudFront can serve content from multiple origins like S3, ALB, or EC2. Geo-restriction. Control who can access your content by whitelisting or blacklisting specific countries. Edge functions. Lambda at Edge. Extend CloudFront capabilities by running serverless functions at edge locations to customize responses. CloudFront functions. Lightweight JavaScript functions to customize content delivery with low latency. Use case. Deliver content globally with low latency and high transfer speeds using a content delivery network, CDN. Example, a streaming service uses CloudFront to distribute video content to users worldwide. By caching content at edge locations, viewers experience less buffering and faster start times. Amazon Elastic MapReduce, EMR. Amazon EMR is a managed cluster platform that simplifies running big data frameworks like Hadoop and Apache Spark on EC2 instances. Key features: Nodes. Master node manages the cluster and monitors health. Core node stores data and runs tasks. Task node runs tasks but does not store data, can be spot instances. Pricing. EMR clusters can use spot, on-demand, or reserved instances for cost optimization. Use case, process large amounts of data efficiently using open-source tools like Apache Spark, Hadoop, and Hive. Example, a genomics research institution uses EMR to analyze vast datasets of genetic information, leveraging the scalability of EMR clusters to perform complex computations quickly. AWS Glue. AWS Glue is a fully managed ETL, extract, transform, load service that prepares data for analytics. Key features: Serverless, no need to manage underlying infrastructure. Job bookmarks, track processed data to avoid duplicating ETL operations. Data brew, clean and normalize data using predefined transformations. Integration, works with Kinesis, MSK, and Kafka for streaming ETL. Determine high-performing and/or scalable storage solutions. AWS Storage Services. Amazon S3. Features: Scalability, virtually unlimited storage. Durability, 99.999999999%, 11 nines. Storage classes, standard, infrequent access, Glacier, etc. Performance tips. Multi-part upload, improves upload performance for large objects. S3 transfer acceleration, speeds up transfers over long distances. Example use case. Scenario, an application stores user-generated content like images and videos. Solution. Use Amazon S3 for scalable object storage. Implement CloudFront for faster content delivery. Amazon EBS. Volume types: general purpose SSD, GP3/GP2, balanced price and performance. Provisioned IOPS SSD, IO1/IO2, high performance, low latency. Throughput optimized HDD, SD1, for frequently accessed, throughput intensive workloads. Cold HDD, SC1, for less frequently accessed data. Performance tips: right size volumes, choose appropriate size and type based on IOPS and throughput requirements. Use RAID configurations for higher performance or redundancy. Example use case. Scenario: a database server requires high I/O performance. Solution: use IO2 EBS volumes for provisioned IOPS. Enable EBS optimization on EC2 instances. Ensure dedicated bandwidth. Amazon EFS. Features: scalable file storage, grows and shrinks automatically. Shared access, accessible by multiple EC2 instances. Performance modes: general purpose, low latency, recommended for most cases. Max I/O, higher throughput, higher latency. Example use case. Scenario: multiple EC2 instances need shared access to a common file system. Solution: use Amazon EFS, mount on EC2 instances. VM import/export. VM import/export allows you to import virtual machine images from your on-premises infrastructure to AWS or export EC2 instances back to your data center. Key features: disaster recovery. Create a disaster recovery (DR) strategy by importing on-prem VMs to AWS. Incremental replication. Periodically update your on-prem VMs with incremental changes to keep them synchronized. AWS Application Discovery Service. AWS Application Discovery Service helps in planning migrations by collecting information about on-premises servers, applications, and their dependencies. Key features: agent-based and agentless, collect server utilization, application performance, and dependency mapping. AWS Migration Hub, track and plan your migrations with data collected from this service. AWS Server Migration Service, SMS. AWS SMS enables you to migrate on-premises servers to AWS by replicating live server volumes incrementally. Key features: incremental replication, synchronize changes to minimize downtime during migration. Well-architected framework. The AWS Well-Architected Framework is a set of best practices for designing and operating reliable, secure, efficient, and cost-effective systems in the cloud. Pillars: operational excellence, perform operations as code, monitor systems, and continually improve processes. Security, implement a strong identity foundation, encrypt data in transit and at rest, and manage permissions using least privilege. Reliability, ensure a workload can recover from failures and meet operational thresholds. Performance efficiency, use computing resources efficiently and scale according to demand. Cost optimization, optimize costs by selecting the most cost-effective resources. Sustainability, reduce energy consumption by using efficient infrastructure and minimizing waste. Design high-performing and elastic compute solutions. Compute services. Amazon EC2. Instance types: general purpose, for example, T3, M5, balanced compute, memory, and networking. Compute optimized, for example, C5, high-performance processors. Memory optimized, for example, A5, for memory-intensive applications. Accelerated computing, for example, P3, G4, GPUs for machine learning, graphics. Auto-scaling. Features: scale in and out based on demand. Scaling policies, target tracking, step scaling, scheduled scaling. Example use case. Scenario: a web application experiences variable traffic with peaks during certain hours. Solution: implement auto-scaling groups, automatically adjust the number of instances. Use target tracking policy, Maintain CPU utilization at a target value. AWS Lambda. Features: event-driven execution, triggered by events. Scalability, automatically scales with the number of incoming requests. Limitations: execution time limit, maximum of 15 minutes. Memory allocation, 128 megabytes to 10,240 megabytes. Example use case. Scenario: process images uploaded to S3 by generating thumbnails. Solution: use S3 event notifications, trigger a Lambda function. Lambda function, process the image and store the thumbnail. Use case: run code without provisioning or managing servers, paying only for the compute time consumed. Example: an online retailer uses Lambda functions to resize and watermark product images uploaded to S3. The function is triggered automatically upon object creation, eliminating the need for a dedicated server. Selecting appropriate compute options. AWS Fargate. Description: serverless compute engine for containers. Use cases: run containers without managing servers. Amazon EMR. Description: managed Hadoop framework for big data processing. Use cases: data analysis, machine learning, ETL tasks. Example use case. Scenario: need to process large datasets for analytics. Solution: use Amazon EMR, set up a cluster to process data. Auto-scaling EMR cluster, adjust the number of nodes based on workload. Determine high-performing database solutions. Database types and services. Relational databases. Amazon RDS. Engines: MySQL, PostgreSQL, Oracle, SQL Server, MariaDB, Amazon Aurora. Features: automated backups, multi-as deployments, read replicas. NoSQL databases. Amazon DynamoDB. Features: key value and document database, fully managed, low latency. Scaling: on-demand and provisioned capacity modes. In-memory databases. Amazon Elasti. Cache. Engines: Redis and Memcached. Use cases: caching, session stores, gaming leaderboards. Example use case. Scenario: an application requires a highly scalable database with low latency for read and write operations. Solution: use Amazon DynamoDB for its scalability and performance. Implement DynamoDB streams for real-time data processing. Database optimization strategies. Read replicas. Description: create read-only copies of the database. Use cases: offload read traffic, improve read performance. Database caching. Use ElastiCache, cache frequent queries to reduce database load. Partitioning and sharding. DynamoDB partitioning, data is partitioned across multiple storage nodes. Use case: handle large datasets and high throughput. Example use case. Scenario: a reporting application requires complex read queries without impacting the main database. Solution: set up read replicas, use for reporting. Implement ElastiCache, cache common queries. Determine high-performing and/or scalable network architectures. Edge networking services. Amazon CloudFront. Features: CDN, delivers content globally with low latency. Integration, works with S3, EC2, ELB. Use cases: static content delivery, images, videos, CSS files. Dynamic content acceleration, APIs, dynamic web pages. AWS Global Accelerator. Features: improved performance, uses AWS Global Network to optimize path. Static IP addresses, provides fixed entry points. Use cases: non-HTTP traffic, gaming, UDP, IoT, VoIP. Multi-region applications, improve global application performance. Example use case. Scenario: an online gaming platform requires low latency for users worldwide. Solution: Use AWS Global Accelerator, optimize network paths. Network design and connectivity. VPC design. Subnetting. Public subnets for resources needing internet access. Private subnets for internal resources. Routing. Route tables control traffic flow within the VPC. Internet gateway enables internet access for public subnets. Connectivity options. AWS VPN. Site-to-site VPN, secure connection between on-premises network and AWS. AWS Direct Connect. Dedicated connection provides consistent, low-latency connectivity. AWS Private Link. Description provides private connectivity to AWS services over the AWS network. Example use case. Scenario: an organization needs a secure and high-bandwidth connection for hybrid cloud workloads. Solution: implement AWS Direct Connect for dedicated connectivity. Network architecture: use private subnets for EC2 instances. Set up NAT gateways, allow outbound internet access from private subnets. Design cost-optimized architectures. Design cost-optimized storage solutions. Cost management tools. AWS Cost Explorer. Features: visualize and analyze AWS costs and usage. Use case: analyze and manage AWS costs and usage over time. Example: a finance department uses Cost Explorer to visualize spending patterns, identify cost anomalies, and forecast future costs, helping them optimize resource utilization and reduce waste. AWS budgets. Features: set custom budgets and receive alerts. Use case: set custom cost and usage budgets and receive alerts when thresholds are exceeded. Example: a project manager sets a monthly budget for development resources. AWS budgets notifies them when spending reaches 80% of the budget, allowing proactive adjustments to prevent overruns. AWS cost and usage report. Features: detailed information about AWS usage and costs. Use case: access the most comprehensive set of cost and usage data available, enabling detailed analysis. Example: an analyst downloads the AWS cost and usage report to integrate with business intelligence tools, providing granular insights into AWS spending across different services and accounts. Storage cost optimization. S3 storage classes. Standard: for frequently accessed data. Infrequent access, IA, for data accessed less often. Glacier, for archival data. Intelligent tiering automatically moves data to the most cost-effective tier. Data lifecycle policies. Automate transition, move objects to cheaper storage classes after a set time. Example policy: transition to IA after 30 days, then to Glacier after 90 days. Example use case. Scenario: a media company needs to store large amounts of video footage that is infrequently accessed. Solution: store in S3 Glacier for archival. Use lifecycle policies, automate transitions. Data transfer and hybrid storage. AWS data sync. Description: automates moving data between on-premises storage and AWS. Use cases: migrations, data archiving. AWS Storage Gateway. Types: File Gateway presents a file interface to on-premises applications. Volume Gateway presents cloud-backed ISC volumes. Tape Gateway presents a virtual tape library. Example use case. Scenario: a company wants to back up on-premises data to AWS. Solution: use AWS Storage Gateway, Tape Gateway, integrate with existing backup software. Design cost-optimized compute solutions. AWS purchasing options. On-demand instances. Features: pay per hour or second, no commitment. Use cases: short-term, spiky, or unpredictable workloads. Reserved instances, REEs. Features: up to 72% discount, commitment of 1 or 3 years. Types: standard REES, cannot change attributes. Convertible REES, flexibility to change instance types. Savings plans. Features: flexible pricing model offering savings up to 72%. Types: compute savings plans, apply to EC2, Fargate, Lambda. EC2 instance savings plans, specific to instance families. Spot instances. Features: up to 90% discount, can be interrupted. Use cases: fault-tolerant, flexible applications, batch processing. Example use case. Scenario: a data analytics company runs large batch processing jobs that can handle interruptions. Solution: use spot instances for cost savings. Additional measures: implement checkpointing, save progress periodically. Compute optimization strategies. Right-sizing instances. Process: choose the appropriate instance type and size based on workload. Auto-scaling. Benefits: scale resources up or down to match demand. Serverless computing. AWS Lambda and Fargate, pay only for what you use. Example use case. Scenario: a web application has variable traffic with low usage at night. Solution: use auto-scaling groups, adjust capacity based on demand. Implement AWS Lambda functions for parts of the application that can be serverless. Design cost-optimized database solutions. Database cost optimization. Amazon RDS. Use RDS reserved instances, save up to 65% over on-demand. Choose the right instance size, avoid over-provisioning. Storage auto-scaling, adjust storage based on usage. Amazon DynamoDB. Use on-demand capacity mode for unpredictable workloads. Use provisioned capacity with auto-scaling for more predictable workloads. Enable DynamoDB Accelerator, DAX, reduce read costs by caching. Example use case. Scenario: an application with variable database load and tight cost constraints. Solution: use DynamoDB with on-demand capacity mode, pay only for what you use. Implement auto-scaling, adjust provisioned capacity as needed. Use case: use a fast and flexible NoSQL database service for all applications that need consistent, single-digit millisecond latency at any scale. Example: a gaming company stores player session data and leaderboards in DynamoDB. The service scales automatically to handle millions of requests per second during peak gaming hours. Migrating databases. AWS Database Migration Service, DMS. Features: migrate databases with minimal downtime. Supports: homogeneous and heterogeneous migrations. Example use case. Scenario: migrating from an on-premises Oracle database to Amazon Aurora. Solution: use AWS DMs, migrate data with minimal downtime. Design cost-optimized network architectures. Network cost optimization. NAT gateways versus NAT instances. NAT gateways: fully managed, scalable, highly available. Cost: charged per hour and per gigabyte processed. NAT instances: self-managed, requires administration. Cost: can be more cost-effective for low traffic. VPC endpoints. Gateway endpoints, for S3 and DynamoDB, free of charge. Interface endpoints, for other services, charges apply. Benefit: reduce data transfer costs by keeping traffic within AWS network. Example use case. Scenario: an application in a VPC needs to access S3 frequently. Solution: use a VPC gateway endpoint for S3, avoid NAT gateway data processing costs. Network routing optimization. Use AWS Transit Gateway. Benefit: simplifies network management. Cost: consider data processing charges. Use VPC peering. Benefit: no data transfer charges within the same region. Avoid unnecessary data transfer. Cross-region data transfer, higher costs. Inter as data transfer may incur charges. Example use case. Scenario: multiple VPCs in the same region need to communicate. Solution: implement VPC peering, minimize data transfer costs. AWS Glue. Overview. AWS Glue is a fully managed extract, transform, and load (ETL) service that makes it easy to prepare and load data for analytics. It simplifies the process of moving data between data stores and performing data transformations. Key features. 1. AWS Glue Data Catalog. Central metadata repository stores metadata about data sources, transforms, and targets. Integration, accessible by other AWS services like Amazon Athena, Amazon Redshift Spectrum, and Amazon EMR. Automatic schema discovery, crawlers scan data stores to infer schemas and populate the data catalog. 2. AWS Glue ETL Jobs. Managed ETL service, runs ETL jobs without needing to manage infrastructure. Job types. Spark jobs, distributed processing using Apache Spark. Python shell jobs, for lighter workloads or tasks that don't require distributed processing. Code generation, automatically generates ETL code based on data sources and targets. 3. AWS Glue Crawlers. Schema discovery, automatically crawl data stores to detect new or updated data. Supported data stores. Amazon S3, Amazon RDS, Amazon Redshift, JDBC compliant databases. Scheduling can be scheduled to run at regular intervals. 4. AWS Glue Data, RU. Visual data preparation allows data analysts and scientists to clean and normalize data without writing code. Features. Over 250 pre-built transformations for data cleaning and normalization. Interactive UI, profile data, detect anomalies, and apply transformations. 5. AWS Glue Elastic Views. Data materialization, create materialized views to combine and replicate data across multiple data stores. Use cases, keep data in sync across databases for real-time analytics. 6. AWS Glue Studio. Graphical interface, design, run, and monitor ETL jobs visually. Drag and drop components, build ETL workflows without writing code. Job monitoring, track job status and logs. 7. AWS Glue Streaming ETL real-time data processing, process streaming data from sources like Amazon Kinesis Data Streams and Amazon MSK, managed streaming for Apache Kafka. Use cases, build real-time analytics pipelines. Architecture. Data discovery. Use AWS Glue crawlers to scan data sources and automatically infer schemas. Populate the AWS Glue data catalog with metadata. Data transformation. Create AWS Glue ETL jobs to extract data from sources, transform it, and load it into targets. Use AWS Glue Studio or write code in PySpark or Scala. Data loading. Load transformed data into data warehouses like Amazon Redshift, data lakes in Amazon S3, or other databases. Data consumption. Use services like Amazon Athena, Amazon Redshift, or Amazon EMR to query and analyze the data. Use cases. 1. Building a data lake. Scenario: an organization wants to centralize data from various sources into a data lake for analytics. Solution: use AWS Glue to extract data from sources like databases and S3. Transform and clean data using ETL jobs. Store transformed data in Amazon S3. Catalog data using the Glue Data Catalog. Use Amazon Athena to query data directly from S3. 2. Data warehouse ETL scenario, loading data into Amazon Redshift for analytics. Solution: Use AWS Glue to extract data from sources. Transform data to match Redshift schemas. Load data into Redshift using AWS Glue jobs. 3. Data preparation for machine learning. Scenario: preparing data for training machine learning models. Solution: use AWS Glue Data Brew to visually clean and normalize data. Export the prepared data to Amazon S3. Use the data in SageMaker for model training. 4. Streaming data processing. Scenario: processing real-time log data for immediate insights. Solution: use AWS Glue Streaming ETL to process data from Kinesis data streams. Transform and enrich data in real time. Load processed data into Amazon S3 or Amazon Elasticsearch Service for analytics. Integration with other AWS services. Amazon S3, primary data store for input and output data. Amazon Redshift, load data into Redshift tables for warehousing. Amazon RDS, extract data from relational databases. Amazon Kinesis, process streaming data. Amazon Athena, query data cataloged by AWS Glue. Pricing: pay-as-you-go. Charges are based on the number of data processing units, DPUs, used per hour. Cost components: crawlers, ETL jobs, data brew sessions. Savings opportunities: job bookmarks, prevent reprocessing of old data, saving on processing costs. Efficient coding, optimize ETL scripts to reduce runtime. 1. Amazon Recognition. Overview: a service that makes it easy to add image and video analysis to applications. Features: object and scene detection, identify objects and scenes within images. Facial analysis, detect faces, analyze facial attributes. Celebrity recognition, identify well-known individuals. Text in image, detect and extract text from images. Moderation, detect inappropriate content. Use cases: content moderation, automatically detect and filter inappropriate content in user-generated images. Access control, use facial recognition for identity verification. 2. Amazon Comprehend. Overview: a natural language processing (NLP) service that uses machine learning to find insights and relationships in text. Features: entity recognition, identify entities like people, places, and dates. Sentiment analysis, determine the sentiment of text, positive, negative, neutral. Key phrase extraction, extract important phrases from text. Language detection, identify the language of text. Use cases: customer feedback analysis, analyze reviews or support tickets to understand customer sentiment. Document classification, organize documents based on content. 3. Amazon Lex. Overview: a service for building conversational interfaces using voice and text. Features: speech recognition, automatic speech recognition, ASR, to convert speech to text. Natural language understanding, understand the intent of the text. Use cases: chatbots, create chatbots for customer service or information retrieval. Voice assistants, build voice-enabled applications. 4. Amazon Polly. Overview: a service that turns text into lifelike speech. Features: multiple languages and voices, supports dozens of voices and languages. Neural text-to-speech, provides high-quality speech synthesis. Use cases: audiobooks, convert written content into audio. Accessibility, provides speech interfaces for applications. 5. Amazon Transcribe. Overview: automatic speech recognition service that makes it easy to add speech-to-text capabilities. Features: real-time and batch transcription, transcribe live audio streams or pre-recorded files. Custom vocabulary, improve accuracy for domain-specific terminology. Use cases: call center analytics, transcribe customer calls for analysis. Media subtitling, generate subtitles for videos. 6. Amazon Translate. Overview: Neural Machine Translation Service for translating text between languages. Features: custom terminology, customized translations for specific terms. Real-time and batch translation, translate text in real time or process large batches. Use cases: multilingual websites, provide content in multiple languages. Global communications, translate communications between international teams. 7. Amazon Forecast. Overview: fully managed service that uses machine learning to deliver highly accurate forecasts. Features: automated ML, automatically selects the best algorithms. Multiple data sources, incorporate historical data and additional variables. Use cases: demand planning, forecast product demand to optimize inventory. Financial planning, predict revenue and expenses. 8. Amazon Personalize. Overview: real-time personalization and recommendation service. Features: custom models, builds models based on your data. Real-time recommendations, provides recommendations based on user interactions. Use cases: e-commerce recommendations, suggest products to users based on browsing history. Content personalization, tailor news articles or videos to user preferences. 9. Amazon Textract. Overview: automatically extracts text and data from scanned documents. Features: form and table extraction, understands the context and extracts structured data. Handwriting recognition, extracts text from handwritten documents. Use cases: document processing, automate data entry from forms. Compliance, extract data for auditing purposes. 10. Amazon Kendra. Overview: highly accurate and easy to use enterprise search service powered by machine learning. Features: natural language queries, understands user questions in natural language. Connectors, integrates with data sources like SharePoint, S3, and databases. Use cases: intranet search, enable employees to search internal documents. Customer support, help customers find answers in knowledge bases. 11. AWS Deep Racer. Overview: an autonomous 1/18th scale race car designed to test reinforcement learning models. Features: simulation environment, train models in a virtual simulator. Community races, participate in global competitions. Use cases: educational tool, learn reinforcement learning concepts. Team building, engage teams in ML challenges. 12. AWS Deep Lens. Overview: deep learning enables video camera for developers. Features: pre-trained models, use or customize models for computer vision tasks. Integration with SageMaker, deploy models directly from SageMaker. Use cases: object recognition, identify objects in real time. Edge computing, run ML models on the device without cloud connectivity. 13. Amazon Augmented AI, A2I Overview, provides a way to integrate human review into ML workflows. Features: built-in human review workflows for tasks like image moderation and text extraction. Custom workflows, create custom human review steps. Use cases: quality assurance, ensure high-quality ML predictions. Compliance, human verification for sensitive tasks. 14. Amazon SageMaker Ground Truth Plus. Overview: provides data labeling services without building labeling applications or managing labeling workforces. Features: managed workforce, AWS manages the workforce for labeling. Quality control, uses ML-assisted labeling for accuracy. Use cases: large-scale data labeling, for projects requiring extensive labeled datasets. Integration of machine learning services. Building an end-to-end solution. Data collection, use AWS IoT or Kinesis to collect data. Data storage, store data in Amazon S3 or Amazon Redshift. Data preparation, use AWS Glue or SageMaker Data Wrangler. Model training, use Amazon SageMaker for training models. Model deployment, deploy models using SageMaker endpoints or AWS Lambda. Inference, use services like Amazon Recognition or Amazon Comprehend for specific tasks. Monitoring and feedback, use Amazon CloudWatch and SageMaker Model Monitor. Best practices. Data security. Encryption, encrypt data at rest and in transit. Access control, use IAM roles and policies to restrict access. Cost optimization. Use Spot instances for training jobs. Monitor usage, use AWS Cost Explorer and AWS budgets. Scalability. Auto-scaling, for endpoints and underlying infrastructure. Distributed training, for large datasets or complex models. Automation. C/CD pipelines, use AWS Code Pipeline and SageMaker pipelines. Infrastructure as code, use AWS CloudFormation or Terraform. Compliance and governance. Compliance programs. AWS ML services comply with standards like HIPAA, PCI DSS, ISO, and SOC. Auditing. Use AWS CloudTrail to log API calls. Monitor resources with AWS Config.